Good morning, Miss. So today we would like to present our model, which is hydraulic drawbridge model. But before that, our group consists of 5 members. First of all, me, Aisha, Azra, Balkis, Nurin, and also Ani. So back to our project, we recreate hydraulic drawbridge model. Actually, this drawbridge model have been used since ancient time, but it is still relevant to be used in this modern era. Additionally, our project demonstrates the Pascal principle, which states that pressure applied to a confined fluid is transmitted in all directions. So now, presenting our objective. We have 2 objectives. First of all, to construct and understand the working mechanism of hydraulic drawbridge. The second one is to apply Pascal principle to make it more efficient. So now, let's hear from Balkis on our methodology part.
Thank you, Aisha. To bring our hydraulic bridge model to life, we follow a detailed 3 phases of methodology, which is design and assembly, testing, and lastly is data and analysis. For design and assembly, we begin by planning the structure of the bridge. Cardboard were selected to be the component of our bridge. For the hydraulic system, we use 10 ml of string and rubber tubes. 2 strings were connected using rubber tubes, and then we make sure to seal all the joints using hot glue gun to prevent any airs from entering the system. For the second step is testing. First, we push one string and we observe if the other string are moved in response. After confirming movement, we move the string to the bridge and do a full lifting mechanism.
For the last step is data analysis. We conducted this step to ensure that the experimental values that we calculated from the experiment align with the theoretical measurements that we did. So we measured the area of the piston and also the force that we applied to the piston to use the formula pressure equals to force over area.
Proceeding to the next part, that is the expected result and discussion. So the result of our model demonstrated the effective application of the Pascal principle that we construct during semester 1 with Dr. Umay. So our drawbridge successfully lifted to a height of 4 to 5 centimeter, supporting a load between 0.1 kilogram. So we built the bridge during the operation, and it remains stable with no significant tilting or imbalance because we put a weight on top of the bridge, so there is no imbalance occur. So we achieve the structural stability to moderate loads. So among the tested fluid, water proved to be the most suitable hydraulic fluid in our trials due to its availability and ease of use. But I consider this as the limitation of our model. For your information, this bridge have already exist in Terengganu, that they have low maintenance, simple components, and minimal risk in case of electrical failures. For in real life situation, they uses electrical to push the syringe in order to lift up the bridge and go lift down back. So from our observation, when the force was applied to the first syringe, the below one, the pressure is transmitted through the tubing cause the second syringe to lift the bridge. So this demonstrates the Pascal principle in real life situation, and also the pressure transmission and force multiplication. It effectively mimic real world drawbridge operation and had advantages such as low maintenance, simple component, and minimal risk in case of electrical failure. However, we also observed several limitations. While water works as a hydraulic fluid, it is not ideal for long-term use. Unlike oil, it can easily evaporate and also corrode metal parts over time, lacks the lubrication properties found in professional hydraulic fluids, such as oil. So, oil can prevent the air bubbles in the syringe, and this will increase the effectiveness of transmission of energy of the hydraulic system. So And also, water leaks can reduce system efficiency and introduce the contamination risk, since water doesn't compress well, such as oil, under certain conditions. So, in our hydraulic bridge model, we use water, and it shows that water actually evaporates inside the syringe and causes the less efficient of transmission energy of our hydraulic bridge. Despite some limitation, the bridge function effective and demonstrate the core principles of hydraulic theory.
In conclusion, our hydraulic drawbridge model successfully demonstrated the practicality of Pascal's principle in railway engineering. To summarize, the project achieved its objective by illustrating how confined fluid pressure can be used to lift and lower a bridge segment. This model highlights how hydraulic systems can be a sustainable alternative to traditional mechanical systems, reducing risk and maintenance costs. We believe this project aligns with the global push for a sustainable engineering solution.
Before we end this video, I would like to acknowledge everyone's role in making this physics-based project to life. Firstly, I would like to thank Pusat Asasi Sains Pertanian UPM for providing us the resources and also the platform for us to make this project work. Next, I would like to thank our lecturers, which is Ms. Aina Sariza and also Dr. Umar, for their encouragement and also their guidance throughout this project. Lastly, I would like to thank my teammates for their consistent effort from building the model to calculating the data in making this project happen. Thank you.